We have started recording. Okay, so last time, let us just recall what we did last time. I'll recall and then I'll start with what today, application of the statistics that we have learned. Okay, so recall that we had done something like number one, a t distribution was z by, right? So what is Vn here? Vn is chi-square n, and z is normal 0, 1, right? Okay, this is what we had seen last time. So if I ask you, what is the expected value of Tn? Am I audible? N greater than 2. So we had seen that n equal to 1 became a Cauchy. It became x z by z z1 and did not have mean, did not exist. Right, we saw this, but I forgot to tell you what will happen if n is greater than 2. What will happen? Any idea? The expected value of z. Can I write this? Yes or no? Can I write this? But I can see it on my screen. I think it's on a problem on your end. Outreach, can you see?
Yes, it came just now. Okay.
Okay, sorry for if there's a delay. So, so the expected value of Tn, can you see what I wrote? So the expected value of Tn is z by Vn, right? This is what I wrote. You recall this, right? So we described a chi-square, what is the sum of Gaussians, and z is a Gaussian distribution. So do you think that, do you accept that I can write it as a product? Why can I write it as a product?
Independent.
Z and Vn are independent. Not IID, but independent. Okay, so now can you tell me if n is not equal to 1, which is a special case, in all other cases, the mean will exist because the denominator will be sum of z1 square, z2 square, root over by n. And so these would exist. These means would exist. And we saw that they would not be equal to, they are not equal to mod z, so it's not going to be Cauchy, they would exist. So what would be the expected value of Tn? And we saw that at n tends to infinity, this became a normal. So therefore, all now would have tails that were, so if you recall, I think I drew the tail of the distribution. Let us check. So I had drawn the Cauchy and the normal distribution this way, and I showed that this eventually turned up to z square. So therefore, after n equal to 1, all the means exist, and we see, you will see in a homework question also what happens in chi-square 2, and you will understand better. But all the means exist. If all the means exist, what will happen? Can you tell me what will happen to the expected value of Tn?
E of z is 0, so
It will become 0. So the better way to better intuition is, so we saw the Cauchy had a very long tail, right? When T1 we had a very long tail. T1 is equal to x by y. We had a very long tail, but Gaussian, the tail subsided and therefore the mean existed to 0. And as n increases, this slowly becomes, the tail shrinks. Okay. And it becomes close to a Gaussian. Tail shrinks and limiting cases is equal to Gaussian. Okay, so that ends all our discussion on distributions. But now how do we apply these distributions? So first question is, in reality, do you agree? So I'll give you, so you can read this when I submit this, I give this file to you, but I'll give you a broader intuition and then we'll try to solve this question, which will give you a better idea. Okay, let me write it at the end. Okay, need for statistical test. Or confidence, right? So I think it's still not here. So I'm having a little bit of a signal problem. Yeah. So need for statistical tests or confidence. So if I ask you, why is there a need to do tests and what are statistical tests, first of all? So I will start with a broad understanding. Say you have a group, right? A group of people, right? And say they have diabetes. Very important in science and medicine. So you have diabetes. You divide the group into two parts. One, you give an insulin, and one part you give a placebo. Placebo is a some sugar syrup. Here you cannot give water syrup, water solution or salt solution, say. And you see the difference in the difference in the blood sugar. Or you see the level of the blood sugar in once you do the test. Now you will have to tell me, say this is 100 and after insulin 110, and without insulin it's 135. Something like this, or let us take it closer, 120 and 135. And you had tested it on 50 participants. So the question is, can you be sure that the insulin is working? Can you be sure that the insulin is working? Or is it just due to random noise? The question is the difference due to random noise? This is the question I want to ask. If it is due to random noise, then I should discard the medicine, right? Are you understanding the overall intuition?
Yes, sir.
Okay. So if it is just like on any other day, you could have seen 120. Is it because of that? Or is it due to the medicine? Similarly, say I toss a coin 1,000 times. I get say 550 heads. Will I be able to conclude that the coin is, can I conclude that the coin is biased? Can I conclude? Any idea?
Hard to say.
You
Not clear.
can't conclude because it can be just due to random noise, right? it has some probability of happening to be 550 heads, right? There is even a probability of having 1000 heads. That is also possible, but it can, but in actuality, the coin may be actually Bernoulli 0.5. But we'll have to check, right? We'll have to find a condition to check whether this is going to be, is actually a fair coin or not, right? So how can I check this? Do you have any idea? So first step one I will do is estimating parameters. Estimating parameters of distribution. Okay. This is the first, this example of the coin where you will have to find out what is the probability of a coin landing head. And the second one I'll see is difference in mean or performance. Are the both use cases clear? I will try to estimate the confidence in my parameters, and I will try to see if the means are different. These are the two use cases. One use case is seeing the means and two, seeing the parameters, right? Okay. So why do we need to do this? In reality, in machine learning, we do not have access to real distribution. Problem. So what is the solution? How do we get, so if the real distribution, say a distribution P of theta, where P is a distribution, or say F theta of theta, where F is a distribution and theta is a parameter. We do not have the actual distribution in our hands. Say Bernoulli 0.5 is an example, right? Example, Bernoulli 0.5. It is one distribution with a parameter 0.5, yes or no? Which we saw was probability of landing heads equal number of times as tails, right?
Yes.
Okay, but we do not have the access to this distribution. What do we have access to?
The data.
We only have access to data. And we need to fit the parameter. So we have to find the data fit. So we have to fit theta. We'll see how we fit theta in machine learning. Fit theta to explain the data. As you may know, so if you see a change in spectroscopy, you can use that difference, significant difference, to say that there is a new element and it is not one of the 119 elements. This is how you do even find new elements. So you have to find the probability of finding a new element and that have to fit the parameters theta. So it's ideally, say your P is not known for the Bernoulli distribution. So what will you do with the P? If the P is not known to the Bernoulli distribution, you have to find P. The people who joined late, we are trying to estimate parameters now. Please go back and see the intuition. So when a distribution has a parameter, particular parameter, for example, Bernoulli P, and P is not known, we only have data and need to estimate P, right? Say we are able to estimate P. Say, we'll see how we estimate P. Say we estimated P. But how confident I am is the question. Okay, so this is the broad intuition of trying to understand what is the confidence interval over your parameter space. So I'll go to the definition. Any questions? Any questions? Is the intuition clear? Okay.
Yes, Adil.
So my question is, say I have defined it, so have a look at that. But the broad idea is, for any random variable x, right? Or a random variable determined by a parameter x. The confidence of the parameter is defined by some mu x to vx. So this is your range in which you are confident about your parameter. Say, I'll give you an example. 0.5 you have predicted to be the p-value for a coin toss. That is the probability of a landing head. But how confident you are from the data, you may come up and say 0.45 to 0.55. This is my confidence level. But now how do I systematically find out this confidence level is the question that we need to ask. So for that, so you can see the definition, let x be a random variable with a parameter theta. So a confidence interval is defined by u of x, comma v of x, such that the confidence level is typically 95% or 99%. We'll see how to formulate this. This is just the definition. So u theta is the parameter. So it should have been, so u theta of x and v theta of x. So theta is your level of the confidence. So if theta is the parameter, you have a confidence over the parameter. So let us take this example and then it will become very clear. So let there be a coin toss that you need.
Can you please show the definition of confidence interval once more?
See, definition is not that important. It is just what I wrote here. For a parameter theta, u theta to v theta is the range, is the range that you need to find for the parameters theta. So you may have estimated theta, but there will be that theta will be within a particular range. We will be confident about that theta. Like for example, 0.5, it can be between 0.45 to 0.55, for example. So let us take this example. Say you have a coin toss and you need to find out. So you are saying, say you have n tosses. So this is also known as, this is in your syllabus, this is also known as binomial confidence interval. Confidence interval or Clopper-Pearson confidence interval. Clopper-Pearson's confidence interval. Okay, so you have n tosses and it is given in the question that there are k heads that you see in the data. Okay, you are told to find out a parameter. So you are told to find a distribution along with the confidence intervals that describes this data. So my first question to you is question 1, part 1. Choose a distribution to model this data. Which distribution will you choose? There are n tosses and there are k heads. So you have to choose the probability, find the parameter or the distribution of probabilities of landing head. So what distribution should I choose?
Binomial.
See, what are you trying to estimate here? The probability of landing head in a single trial, right?
Okay, then Bernoulli.
Bernoulli.
So I will generate, because say I am giving you a coin, I'm asking you what is the probability of head in the coin. So how will you do that experiment? You will toss the coin multiple times and tell the average number of heads, right? That's your intuition. That is what you will do, right?
Yes.
So, but you are trying to find out for a single trial, right? Single coin toss. So your single coin toss xi will be Bernoulli P, and there will be IIDs x1, x2, dot 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 xn. Do you agree? All of them will be Bernoulli P, same coin. I hope it is clear. Now my question is, what is the parameter you want to estimate? So which parameter you're trying to estimate here?
The probability P of getting ahead.
Yes. So you're trying to estimate probability of xi equal to 1 or equal to p. What is it? So what would be your guess for p? Say your p estimate. Let us denote as the estimate as this. What would be your estimated value? And how would you estimate it? This is also a question. So how would you estimate it and what would be your estimated value? Any idea? I had taught you a law and I derived it saying it's the law of large numbers. Do you recall?
Yes.
So what was the law of large numbers? It was
The sample mean goes towards the actual mean, and
goes
biased variance.
goes to 0, and there is no other moments. We showed that the probability of the sample mean being away from the actual mean goes to 0 as n tends to infinity, right? So the
Yes.
probability of x cap minus the actual mean greater than epsilon was less than equal to variance of, we showed that variance of xi by some n epsilon. We had shown this. And we showed that limit n tends to infinity, this goes to 0. Right, we had shown this. So I will use, so this is how I will estimate. Use law of large numbers. Law of large numbers, right? I will try to estimate the p hat using law of large numbers. So I will see the observations on the data and I will take the mean. So what will it say? You are told that there are k heads. So my estimate p hat will be k by n, right? This is my estimate. Agreed? If there are k heads, there are k ones, right? And n minus k zeros. Agreed?
Yes.
So there will be k by n. Normally, say 1000 coins, 550 heads. So you'll get 0.55 as the probability. Okay, as the parameter. So how will you estimate? What law of large numbers will you use? We have done. Now I am telling you
K
what
by
is
n,
your
কি করে করলে?
yeah.
K by n, how did you do?
So I have the data, right? I have k heads. I've given k heads occur in n tosses, right? And I have modeled the, I know by law of large numbers, this mean will converge to the actual p. Yes or no?
Yes.
The sample mean will converge to actual mean. So what are xi's? Xi's are Bernoulli random variable you have defined.
Yes.
So if there are k heads, how many of them will be one?
K of them. Yeah. Okay.
So the sum will be k. Yes or no? K of them are ones, rest are zeros.
Yes.
Therefore the sum is k. Therefore I will have an estimate as p hat as k by n. But how much confident am I about the k by n? So again, I have taught you another theorem in probability. See, I'm using all those theorems very nicely over here. What did I show you? That the distribution of x hat, what will be the distribution of x hat? If you recall,
Normal.
very good. Ryotrij, you remember we did that? X hat will be normal. We'll write the parameters mu and sigma. Wait, we'll put the parameters. Do you agree? What is the rule that we are using here? That x hat will be a normal distribution, the distribution of x hat in general. This is a special case of the distribution. It's a sample. As O3 was asking me what is a sample and what is a distribution. So this is one sample of x hat. And I have to see what is the validity of the sample. That's what I have to see. So my question is, what would be the distribution of x hat and why will it be normal? We are shown using central limit theorem that the sample mean converges to normal mu sigma square or sample minus the mu. So what had we shown? We had shown Sn minus n mu by sigma root n converge to normal 0, 1, right? You recall? Where Sn is the summation of xi's I equal to 1 to n. Or in other words, summation of I equal to 1 to n, 1 by n xi minus mu by root sigma converge to normal 0, 1. Do you remember? This is the central limit
Yes.
theorem. Central limit theorem. So therefore, what will the summation of I equal to 1 to n, 1 by n converge to? So if I write this as z, what will it converge to? Mu plus sigma by root n into z. Yes or no? What is this distribution?
Normal mu sigma.
Normal mu sigma square by n, right? This is your sigma.
Yes.
This is your sigma tilde or nu sigma, and this is your mean. Please study. Please go back and study. So we defined any normal mu sigma squared as mu plus sigma z, if you recall, where z was normal 0, 1. Okay, I have backtracked to the first class again. So this is your, so what will x hat converge to? It will converge to actual p, right? Yes or no? Let us write the mean for the time being, and sigma by root n whole square, that is sigma square by n. We proved just now, yes or no? By central limit theorem, this will what is converge to. Any questions you ask? Therefore, it will be a normal like this, with the mean here. This is going to be your mean, right? This is going to be your mean, that is your mu. Okay. Sure. Can you hear me and see my screen?
Yes.
Okay, so you agree with this, right? Or no? Any?
Yes.
Okay. So if you agree with this, so you are told to find the place where you're 95% confident about your estimate of P. Where will you be 95% confident? In which region? In this region, yes or no? Where you will have 95% of the mass of the standard deviation of the normal.
Yes.
You will be confident somewhere over here about the mean. Right. So what is your mean? What is the mean? So we know that, yes, so x hat converges to the actual P, right? Or x hat converges to the actual mean. What is the actual mean? That is P. Yes or no? Here in this case, what is the distribution? Bernoulli P? Yes or no? I think Brahmojit solved this question, right? From Bernoulli P, you made a Gaussian. Same question you solved. You're not telling me. You had plotted it on the group, right?
And I've plotted the CLT. Sample from a uniform and plotted the CLT.
This is from a Bernoulli. So do you agree that x hat will the expected value of x hat is going to be mu, which is actually P? Yes or no? P is your distribution that you're modeling. Let us not write expected value of as, let me just clearly define if you have any doubts. So your expected value of xi is equal to P. Yes or no? Right? That's how we have modeled.
Yes.
Yes.
And what is the variance of xi? Say this is equal to mu. I'm just writing in case you're forgetting. And this is your sigma squared. What is your variance of xi? We had proved it was P into 1 minus P. Do you remember? Or you can just do it. What is the variance of, what is variance? It's the expected value of x squared minus expected value of x whole square, right?
Yes.
So what is the expected value of xi squared? It is 1 into probability of x equal to 1, right? Plus 0 into probability of x equal to 0 minus p squared, which is your expected value, as you have told me, which is equal to p minus p squared is equal to p into 1 minus p, right? Yes or no?
Yes.
Okay. So my variance I know, my mu I know. Now I have to know how to find out the region of this 95% confidence. So my expected value of this, I don't have access to P, right? What do I have access to? So mu I know, variance is P into 1 minus P, right? This also I know, root over. Sigma squared is P into 1 minus P. So this is this, right? So what is your normal distributions mu and sigma then? Bromojit, can you tell me? Artho, can you tell me?
Mu is P, sigma squared is P into 1 minus P.
So this is gonna be mu normal P, sigma square is P into 1 minus P, right? So this is gonna be your normal distribution according to the central limit theorem. Good.
Oh, now are we
Then-
going to use the CDF to find which
Exactly.
influences
We'll see.
95%?
Yes. So now I know this
So here
distribution,
what
right?
Here what we are doing is we are mapping a Bernoulli variable to a normal using the law of large
Because
numbers.
yes, because the law of large numbers says that first I will use law of large numbers to say that the actual mean will converge to the data mean. And I will use central limit theorem. This is not law of large numbers, central limit theorem, where that the mean converges to mu sigma square, right?
Okay.
Yeah. So by central limit theorem, I'm mapping that. Good. So now I want 95% confidence. Can you tell me how will I get? 99% is your homework. This is your homework.
We'll take some phi of z. So phi of z minus phi of minus z will be equal to 0.95.
There is a easier way. So
There is
see,
we already have this thing mapped to the normal distribution. Now we can simply use Z-score table.
Z-square table you can do, but what is this area? What percentage is on this tail? 95% is in the
5%.
center.
Oh,
5%.
no. 2.5%.
2.5%. Others, it is clear. What am I using, Uttrij, here?
Okay, means sum of all areas will give one.
What property of the what property of the normal am I using? So your mean is at the center. So it's like how much can you cover the mean? That's the idea on both sides. So both will be symmetric. What property am I using? The symmetry, right?
Yes.
Okay. So now I need to a 2.5% in the tail. So 2.5% means what is the CDF? What is the CDF, Uttrij? If I calculate the CDF, I have to find this Z. Then how will I find?
Okay, like CDF equals to 95 plus 2.5%.
Very good.
From
So
that we'll
CDF
get
is what is the definition of CDF? Minus infinity
to 9 to Z. Yes.
to Z 1 by 2 pi. I'm doing from normal 0 1 e to the power of minus Z square by 2, right? Is it? Always use normal 0 1, not any other normal. I will show you. That's why we have the rescaling formula. And does this have to be 97.5%, right?
Yes.
For 95% interval. For for confidence equal to 95%. Good. So this is also, we have defined this as phi of z. So I will get z as phi inverse of, so you can use the table or use a computer. I have in your assignment, I have given you to use the computer. This turns out to be 1.96. I have calculated it before only and kept it. Okay. This is the value I need, 1.96. So now if I tell you what would be the range, so I got this z value. Do you agree? This z value. You agree? Isn't it? So this is your distribution of the x hat. Yes or no? And that is distributed as mu
Yes.
plus sigma by root n into z. Z is how much? 1.96. Agreed?
1.9.
Good. So now what is your, in which range will you get? So now I need two things. So I need, what is the estimate of mu? Where have I got the estimate of mu from? Tell me. What is the estimate of mu?
P.
Good. So let me just write it. So I know my formula now. I know that my okay, let us first write the confidence interval without using the estimate. And then you will tell me, you only will tell me. So we showed that this distribution is mu comma sigma square by root n. Yes or no?
Yes.
Okay. So do you agree the mean is at the center?
Yes.
And we showed that it is at 1.96 if you 1.96 times standard deviation. Yeah.
So wasn't that sigma square by n?
N, right. So sigma square by, it is 1.96 times the standard deviation away, right? We have shown that, right? Here we have shown 1.96 into standard deviation away.
Yes.
So it is, and the value of z I have also obtained. So 1.96 standard deviation away is my confidence on both sides, right? 1.96 into sigma by root n. So what is your range of confidence? Tell me, confidence interval will be?
Mu minus 1.9696 sigma by root n to
Very
plus.
good. Sigma by root n to. So this is all the, so we are using all the proof things that we have now. You will feel the feel good factor. See, everything that we have learned, we are using to do this. This is also something like machine learning, but it's statistical learning. Okay. So this is your confidence level, but I do not know mu. I do not know sigma. What will I do? I have an estimate of it by law of large numbers. What is the estimate?
Yes.
By
Mu is
law
P,
of
sigma.
K by n is your mu estimate, and sigma's estimate is, which is equal to p hat into 1 minus p hat, right? We just now found for the Bernoulli.
Yeah.
So that is equal to k by n into 1 minus k by n. Yes or no? Clear? So my range of interest is confidence interval. If I am, this is called the binomial or the Clopper-Pearson confidence interval, is p plus minus, what is the range? P is your k by n, 1 minus k by n by 1 by root n into 1.96 for 95% confidence. And this can be, you can just put some factor f, and you have to just find that how many, what explains that, right? Right. So you can just put z here. In our case is 1.96, right? So if you are told to find 99% confidence, what will you do? What will change here? Which one will change?
So Z value we will calculate by putting
Based
99%.
on, so 99% hole, this will be 0.5%, right?
Yes. So
So
99.25%.
99.5%.
Yes, yes, yes. Understood.
This side also you will have 0.5, na? And then you will calculate. Okay, now you have told to find it for 520 and 1000, I think. So let us put the value and see. So what is the value of k equal to 0.5, of k equal to 520, n equal to 1000? What is the value? So this will turn out to be 0.5 to 1.96 by, what is the value of n? Root n into 0.52 into 0.48. Yes or no? Agreed? Let me just calculate this. 1.96 into 52 into 0.48 divided by 10 divided by 10. This is equal to 0.52 plus minus 0.31. Okay. Now, Trij, can you tell, or anyone, can you tell me that what will happen if n tends to infinity? This confidence interval is also giving me that idea. As n tends to infinity, what will
The
happen?
confidence interval is gonna be sandwiched, it seems.
Yes,
Like
so it
this.
will become just k by n. So that is also your law of large numbers, right? Even using this, you can show law of large numbers. Yes or no? It will be sandwiched if n tends to infinity. That's what you expect. Everyone, it's clear to you all? Can I proceed?
Yes.
Okay. So my second question is, so I have done it for a normal. Now, second question, you may be asked in exams to find for a list. What is the confidence of your median? So this is just application of this formula. Okay. So let us do this. You are told to find the. I'll just copy this list. Copy. Question number 2. Yeah. Okay. So I am telling you what is the confidence of your. What is the confidence of your median? What will you do? What will you do? If you're told to find the confidence of the median, first step, what should it be? Like last time I found. So this is also,
So
yeah.
finding the distribution of the median.
You don't know, you just know the data, right? Say you're given k models accuracies. So the median accuracy, you want to find the accuracy of the median. This is something like that. Understood? Say normally what you do, you say have k models and they have accuracies. And the median accuracies distribution you want to find, or the confidence you want to find. So, but you don't know the actual distribution, right? But you only know the samples. So now I will take this as the sample. This is the median, sample median, yes or no? Whichever is in the middle is the sample median. This is 19, yes or no?
Yes.
Okay. So now, how much confidence can I give that 19 will be the median? That 19 will be here and not 11, 16, 22. No, why? How can I be confident that it is not by chance? Again, you recall what was the formula that I used? K by n into k by n, 1 minus k by n by root n into z. This formula we have used. right? So the question arises, the question that I want to ask is what will happen to the distribution of the mean? How will I know where will it be? Where will it be? So this was your, in your probability sense, what was the distribution of the mean, right? Here you are finding the median, but for large samples, we assume the median and the mean to have similar characteristics. But anyways, we can use the same formula. But we have to be intelligent enough to find out what is the exact point we want to get the value of, right? We have to be confident of that. So, but here I know this k by n. This k by n must be known to me. Can you tell me what is the k by n? So this here I will write this n as a different n for the time being, n tilde. Okay, I have a reason to do that. There's an intuition to do that because I already know the value of k by n. If you do not write k by n, which was estimated, do you remember it is nothing but p into 1 minus p? Do you agree? Let us not write k by n, then there is a confusion. Okay, p into 1 minus p, this was your confidence interval, yes or no? Clopper-Pearson?
Dada,
Paul?
yes, means here we have only one data set. So how can we estimate using one data set? That is the main
This
problem.
is not one data set. You have to think that 19 is there, but how confident are you that the 19 is exactly there? So you have to tell me in this data set, which are the two numbers that you will be confident that the median will lie between, right? So for example, I'll give you a better answer, say 45% accuracy is one model, 48% accuracy is one model, 50% accuracy is one model, 52% accuracy is one model, and so on. You have many models like this. But yeah, you will tell, but let me just clarify that out. But say the median is 52%, right? But you are not confident that the median is 52. You have to tell me that the median can be between 48, this sample, and somewhere here, right? Understood? In the list, where can the median actually be? You are hoping that this is from some underlying distribution f, right? This is your distribution f, underlying distribution f. Okay. And 19 just came out of a coincidence. And we see this is exactly not a correct way to do it. You are right. But statisticians or biologists often do this, or even in machine learning, we do this because this is the most intuitive form to do it. Right? So P, what will be the value of P for the median? You tell me. Median is 50% of the data, right?
Yes, sir. 0.10.
0.5. Yes or no?
I didn't understand this formula. P is equal to 0.5.
You are told to find the confidence of the median. Yes or no?
Yes.
So if you just take proportion, where is the median placed? It is the place where 50% of the data cuts, right? Where 50% 50% is before and 50% is later.
Percent is yes.
So to find the median in a particular list, where will you? I will tell you why is this? Why am I taking 50%? To be exact. So here you are telling 0.1. I understood because it's 1 by 10. No, it's not like taking 0.1 directly. The idea is to take in this entire data set, what is the probability or the position where you'll get the median to be. So you'll get the median to be exactly in the center, right? As you, so the in the list. So a better estimate is just to see the product of NP. If you see NP, if you n is confusing you, let me multiply n with this. So now I have a term called NP and I have NP1 minus P. Okay. This is what I have. Now do you see the intuition? What is happening? So NP, I want to find the location. So NP is the location of the median, right? If I have to make NP the location of the median and build a confidence, what has to be P? N is the number of samples.
Yes, then half, because at center.
Isn't it, Partho? Your class 10, you found the index of the
Yes,
median
yes.
by n plus n by 2 th index, or n plus 1 by 2 th index, yes or no? For large indices, it will be just NP,
Yes.
right? So this is considered to be the median. Now, if I take this to be the median's position, now I have to find how much does it vary. So for this, P has to be 0.5. So this is not exactly using law of large numbers, but using this Clopper-Pearson interval very cleverly to find find a confidence for the median. So now, for finding the position of the left and the right, what will I do? I have again multiplied n, right? So this will also give me a position. Do you agree? Yes or no? So in the entire list, I will get two positions across between with the median in between. Agreed?
Yes.
So since think of this distribution. Say you have this distribution like this, and we found it in terms of P plus minus Z, P minus P by N, right? This is how we found the thing. But my question is, since P is some number, I have to find, I only have samples from the number. These samples I have. So to get the middle sample, how much do I have to multiply this with? So to get the middle sample, I have to multiply N, right? And I have to set P equal to 0.5. This is the index. I am finding the index. This is just finding the index of the median. Okay, Partho?
Uh,
How do you
in
find the how do you find the index of the median? You do n by 2, right?
Moina, I'm not understanding any part of this. I'm genuine also. মানে
What
Clopper-Pearson
is
টা
the
কিভাবে
index of the median? I'll just ask you. Index of median
n
in a
by 2?
list. N by 2, yes or no?
Yeah, yes.
So I am just setting P to be half. I'm setting P as 1 by 2 just to use this interval.
Yes.
So what are you not understanding? So this is, if you're told given a list, how do you find the median? This is what I'm asking.
হ্যাঁ মানে that মানে Clopper-Pearson টা কিভাবে ফিট করলে এখানে আমি কিছু বুঝতে পারছি না মানে that p into 1 minus p টা means how did you rough it up?
So how do you come up with P into 1 minus P? You're asking.
Yes. No, মানে
I am
we did
the
Clopper-Pearson and from there you have placed this. But
say you have now if you're given a list, you cannot use probabilities, right? Do you agree? You just cannot use the probabilities directly. What does the probability of a
no,
list mean? So I have to do a trick to get index. So how to convert probabilities into index in a list?
total number of elements into that.
দিয়ে multiply করতে হবে, তাই তো?
Yes. Yes.
Probability to index, how will I convert? Multiply by number of elements. Now is it clear? So you have the interval, you are trying to fit this
Okay.
Gaussian on this list. You're trying to fit this Gaussian on this list. That's the idea. This is a post hoc correction. This is not actually correct. Okay.
So I'm trying to fit that Gaussian onto this list then.
Yes.
What is
Suppose
my z in this case?
what is?
Z is the n01 variable and Basically, I'm trying to. Okay.
Only
Fine.
you need to have an ascending order list and you have a Gaussian confidence interval. Is it okay, Utrij? You have the confidence interval for a Gaussian, but you want to fit the list to that Gaussian in some way. Others, it is okay?
Yes.
So, so you have some index. So these are in terms of probability. So how will I convert them into indices? If I have to fit it in the list, how will I convert the probabilities into indices? And I know that the index or the position of the median is at 0.5. So I will put everything as 0.5, 0.5 plus minus 0.5 squared into n into z. Or rather leave this. These are the probability or the confidence probabilities, right? This is my confidence probability, yes or no? Of the median. Just from this is just using the Clopper-Pearson interval.
Yes.
You understood once, again it became unclear. What is if that not became that did become unclear? Is it okay?
Yes.
Hello, am
For
I
me.
audible? Partha, is
Yes.
it okay
Yes.
now?
Yes.
No. You would ask what is the issue? From index to a
Moinazda,
probability. Yes.
দেখো মানে let's start মানে Clopper Pearson we found out the 95 confidence interval in Clopper Pearson, but that
Correct.
p into 1 minus p, it's not at all I'm being able to perceive that how you are applying a Bernoulli over here,
How is it that? How is it you're
that you
not
are
able to
applying a
parse?
Bernoulli over here.
Exactly. That's a then that is what you should ask. How are you applying a
Okay,
Bernoulli over here?
can I guess means the median can be the median element with a 0.5 probability, or can't be with
It
a
can be
0.5? Is that it?
yes. Yes, the median element can be either on the left or the right. So this is the simplest way to the simplest Bernoulli estimation of the median. This is the Bernoulli 0.5 approximation of the median. So if you are having, so the idea is a mean is very similar to a median, right? The mean is sort of the weighted average and you take the average at the center. Do you agree? Yes or no?
Mean is the weighted, yes,
Mean
weighted
is
by
very
the.
for yes for a similar distribution, mean is very similar to the median. For Gaussian it is same, right?
Uh, yes, since it is symmetric.
50% of the data is on the left, so
Yes,
50%,
yes.
if that boundary that covers 50% of the data is called the median. So the question is, if I was telling you this is the mean, then you would have no issues, right? So you had some mean of a distribution, say 0.5 or whatever accuracies you have, and so
Hmm.
on. Then you had no problem, right? So if it was a mean of
If it
using
was a
this,
mean,
some accuracy, some other term, and so on. So you have these terms, right? So you have these numbers that is fit, and you do not know any other probabilities to use. So the idea is the median can either be to the left or be to the right of the distribution, right? And if you are taking a list, it will be exactly in the center. If you are taking a list, the mean is if the mean is very similar to the median, then you can, do you agree? Can you use the Bernoulli or not? Or similar distribution where it is 0, 1. P, where P is the probability of being the median. So let us take this example, it will become clearer. So if I put multiply n to this, so I get n into 0.5. And I get z times 0.5 squared into n. In this list, I had 9 examples, I guess. Yes. So let me just put 9 examples. 9 into 0.5 squared into z. This turned out to be z into 1.5 plus minus 4.5. Okay, and you put z equal to 1.96, whatever you want to put. Now, your question is, if I have this, why am I using p into 1 minus p? My answer to that is, think of it like a coin toss. Think of it like a coin toss whose outputs have been arranged in this order, right? So, for example, let us take this. So you do a coin toss, right? From Partho, please unmute. I'll tell you why. I think this you can relate with this.
Okay.
So you say you do a coin toss 1,000 times, okay?
Yes.
You will. Do you agree that you will get a Gaussian distribution? If you take the samples of x hat, if you do it multiple times in 1,000 times.
So okay, so I am doing it 1,000 times. I am taking the exact in each time, right?
Yes. Okay.
Here n is equal to 1,000.
Anything. Here it is 9 or anything.
Okay.
I will take average. It will be number of heads by 9, right?
Yes.
So you will have a histogram like this. Yes or no? If you do the experiment multiple times, sometimes you will get 4 heads, sometimes you will get 6 heads. Yes or no?
Yes.
So from 0 to n, you will have a histogram like this. Now, instead of the histogram, you are given only a list. So this list can be just taken as a, it is not any probability, it is some particular list, right? In some particular list where this is mapped to 19. The next one is mapped to whatever numbers you have. They're mapped. There is a 1-1 mapping between this histogram and this list, right?
Yes.
If I map it, now do you agree that I will have a confidence interest interval for this list? Or for this distribution histogram, and there will be a
Yes.
1-to-1 mapping to this list. Mapping to the list.
Yes.
So that's what I'm doing, right? So I'm just multiplying by n. That will give me the list index.
Ah, okay, fine.
I thought this was obvious. That's why I was not telling. So you're mapping between binomial. Good that you're asking the question. Between binomial, you should ask like this. Very good. Bernoulli P and the list. And therefore, you would be able to, by central limit theorem, you would be getting a histogram, and then you would have the similar bounds for it, and then just multiply n to get list indices. Is it okay, Utresh?
Yes. Means actually the problem that I was facing was because in the previous example you gave the input like k by n, we had k and we had n, but
Yes.
here we are considering the ideal median, that is 50% or 0.5.
Correct.
So we are assuming and
Correct.
then
So
proceeding.
here it's an arbitrary list. It is not always true. It is mostly used. I was just trying to show you the example. It is used when we are doing some accuracies. Say you have K models and you have a list of accuracies from the models, right? And then you will tell what is the confidence of your 50% or your median accuracy. Okay. There it will be like more like a Bernoulli, right? Parts of accuracy will be more like a Bernoulli. Here it's just a label to this positions. Here the list is a label to these histogram. You can think of it this way. So now you can find, if it is required to find if you have a model, when you're training machine learning models, you train K models for cross validation and whatnot. You train based on changing hyperparameters, you get K accuracies, and you will be able to tell the confidence of your accuracy, right? Also understood now the intuition why I am doing it for a list.
Yes.
Good. In that case, you would not have the actual distribution given to you. Okay, so with that, let us come to the second use case that I was talking to you about, seeing the differences in means. I don't think this will take a lot of time. This is much simpler than the confidence interval. So what was the intuition I was giving? I was telling that you give insulin to one of the diabetes patients and you give placebo to the other diabetic patient, right? And you see if the means of their blood sugar level changed or not. And then you will be able to see if the medicine was useful, right? Do you agree? You have to see effect of a medicine. Useful when seeing effect of a medicine. Does a change in a model improve accuracies? Improve accuracy significantly, and so on. So if you recall the example, I gave an example of a, so I'll go to that example once again if you forgot. So yeah, so you have 50 participants and you give half of them insulin and half of them you do not give any placebo. You give them some placebo salt solution. So now you see the blood sugar level is some grams per cc 120, and you see some milligrams per cc 135 milligram per cc. And then what you're trying to do is you're trying to see if this difference is actually true. Is it due to the medicine or is it not? Is the question motivation clear? Okay. You're trying to see if the difference is. So I have taken an example over here. This will give you a better understanding. Say a mean height of a population is 175. The standard deviation is 10 centimeter. A health drink of the product on 500 kids show that their height goes up to 180 centimeters. The question that the health drink company will ask and show it before the consumers is, was this increasing the height significantly or not? Understood? Correct?
Yes.
So here, first of all, before we do the math, there are two hypotheses here. What are the two hypotheses? Can Utrecht give you can you give me an intuition of the two hypotheses? The question is yeah, tell.
Like assuming the mean to be 175, we had variance of 10 centimeter.
No, I am what is the hypothesis is the conclusion theory, right? Hypothesis is a theory that has to be proved.
Yes.
So the question is the health drink beneficial? Is the question. So what are the two hypotheses possible?
Oh, like it is
Yes.
not beneficial because it
Good.
lied between 175 plus 10, and the other one is it is beneficial because it has changed the mean.
We'll see. It is not beneficial. It is beneficial. That is, it changed the mean. Good. Now, my question is, how do I do this? How do I get a theoretical way to understand if the mean really changed or not? Again, what is the theorem I will use to see if the mean changed? Whose distribution will I check? To see the mean, so we are doing Z test now. I am trying to see if the mean changed in distribution. So whose distribution should I check to check if the mean is changed or not? Tell me, whose distribution should I check?
Height.
Let us write. Let's forget height for now. Say mean. Again, mean I can use, right? 1 equal to 1 to n, 1 by n, xi. Partho, can I use this? Let us understand the theory of this. Then we'll do the practical solution. Can I use this is the distribution of the mean? Yes or no?
Yes.
I will take n samples, 500 samples, and then take the average, empirical average. This is the distribution of the mean. So if I tell you xi is distributed as, so this is the assumption in the Z test. Assumption, xi is distributed as mu sigma square. Okay. Assumption is all of these are distributed as mu sigma square. What is x hat distributed as? By law of large numbers, what is it distributed as?
N01.
In 0, 1, what is the distribution of x? X hat.
Oh, mu sigma squared by root n.
What is the expected value of x hat? 1 by n, expected value of xi. Yes or no?
Yes.
This is equal to mu. N mu by n is equal to mu. And we showed the variance is variance of x hat. This is fourth time I'm doing law of large numbers. X hat is 1 by n, variance of I equal to 1 to n xi. Yes or no?
Yes.
What is it?
Sigma squared by n.
N square into n sigma. It is sigma square by n. Okay. So we see that the mean has this distribution. Now, can you tell me, I have taught you enough of statistics for you to tell me how will I solve it? How will I solve this problem? So I know the distribution of the mean. Okay. I know the distribution of the mean. Right. And I want to
Yes.
say, I'm asking, I'm asking you if the mean actually changed. This is the distribution of the means. So if the mean actually changed, where will that mean lie? If mean changed, where will it lie?
95% interval.
So I have not said 95% or anything. Say the mean. I am asking you. Say the confidence is theta. With gamma confidence, you have to tell me if the mean changed. Okay. Then what will I do? In other words, let us also try to find out what is the probability of the tail. Probability of tail. Then you will find the thing easily. Say your new mean that you have is somewhere here, right? Your mean new, right? Agreed? Yes or no? If the new mean is 180, it will be somewhere outside.
Yes.
So there will be a distribution towards the right hand side. Yes or no? There will be some mass to the right hand side of this x nu. Yes or no? This is what we are defining as p tail. This is probability of x hat greater than x nu for our case. Is it clear? So let us define, this is called a p-value. I will tell you why it is important. It is called a p-value. Yeah, you're unmuted. You have a question?
No.
Is it okay that with the tail distribution, did you understand? What am I calling the pay tail distribution? And I'll give you the intuition of what is the tail distribution. So another x here is another mean, right? Another mean of the heights. Yes or no? If this probability is very low, can I say with certainty that it is not possible? What can I say with certainty? That your x nu lies in the tail, right? Yes or no? Let us take an example. So we have understood that the distribution of x hat is distributed as what distribution?
Normal.
Nor mu sigma square by n, right? This is what is distributed as. Okay. So now you tell me, if I take a statistic, this is called a z statistic. Anyways, it is called a statistic. And I take x. This is not fair reading. Minus mu by sigma by root n. It is in which distribution? This is according to which distribution? So this is sample to which distribution? Can you tell me?
Okay,
Z
it will be N01.
Normal 0, 1? Yes or no? If I take, this is the distribution of, correct?
Yes.
Okay. So my question is, if I get a particular value of x, so let's say x cap is some x naught, right? Then your z naught is what? Z naught minus mu by sigma by root n, yes or no? Or x naught by mu, yes or no? This is where the z will lie. This is your z naught, yes or no?
Yes.
Okay. So if I'm, I'll stop if it is. So now I am telling you what is the probability that, let us find this probability z greater than z naught. What is the probability? How will I find?
Like 1 minus CTF of up
1
to Z
minus
naught.
z naught. 1 minus phi of z naught. Yes or no? This is defined as the p-value. Why? Let us see in this example, you'll understand. So the question is asked to us is, what is the height of the average population? Mu is given to us. What is mu?
175.
175. What is x naught after health drink? 180, I think.
Yes.
Right? What is number of people? N? 500. And sigma also is given is 10, right? So what is your Z statistic? What is Z statistic? Just means what is your position of the Z on the normal distribution? Where is it on this x-axis on the normal? That is just Z statistics. There's nothing else. So Partho, tell me what is the Z statistics here? What is Z naught?
Sure.
It is
It is x naught minus mu by sigma y squared away.
so X naught. So do you agree that the Z distribution is X minus mu by sigma by root n? You only told me. Yes or no?
Yes.
So any sample from the distribution will have a particular position in this x-axis, yes or no? If I take x from this height distribution, I can convert it into 0, 1 distribution, yes or no? I can scale it back to 0, 1 distribution, normal 0, 1.
Yes. Yes.
How will I scale it? 180 minus 175 by
182 by sigma 10 by square root of n 500.
100. Yes, what is this value? 5 by 10 into 10 root 5, right?
Yes.
5 root 5. So what am I telling? Your Z statistic is equal to 5 root 5. So do you agree that this is almost in the tail? After 1.96, it is only 2.5% of the distribution remains, right? Yes or no? We saw just now. So if I am
Yes.
told, so p value of 1 minus p of 5 root 5, this is almost equal to 10 to the say 10 to the power minus 6 or 7. So p is equal to 1 minus 10 to the power minus 6 or 7. So what is this giving you? So this is giving you a probability that, so if p generally is less than 0.05, that is 5%, then you discard the null hypothesis. That is, there is no change. Where is it? We define the null hypothesis. That is not beneficial, no change. This is called the null hypothesis. Null hypo. And this is called alternate hypo. Okay, so if there is no change, do you agree it will be within 95%, sort of like to be conservative? Just to be conservative, we take it to be 95%. You can take 90% also, according to you. Do you agree, Partho?
Yes.
I am waiting. So I am saying at 1.96, we showed that it was how much percent of the distribution?
95.
95 or 97? 97.5, right?
97.5. Yes.
So if there is an increase and you are seeing it as 5 root 5, it is far away in the tail, yes or no? 5 root 5 is far away, far greater than 1.96. I don't think you can disagree with that. .5 is on the x-axis, okay, and the probability of z is on the y-axis. I am finding the x-axis value. It is 5.5 I found, and I found it is far greater than 1.96. Yes or no? 5.5, 5 root 5 is greater than 1.96. Do you agree? Okay, if you don't agree, I can't do anything about that. So it is far in the tail. So you are saying that it is only possible when it is so less probability. So it has less probability of 10 to the power minus 6, then only the mean can have same distribution. The probability of having the same distribution is 1 minus 10 to the power minus 6, which is very low. So I can discard the hypothesis. Discard and H0 and say the hedging was beneficial. Clear? No?
Yes. Dada, like what is the significance of P then? 1 minus P says that how much area we have remaining.
That is the P. That is not 1 minus P. That is P. 1 minus this theta that you found. That is the area that you have remaining. What is the area of the tail? P value gives you the area of the tail. So if generally P value is less than 0.05, you think that there is a change. because 95% of the time there will be a change, right?
So how can p value give area of tail? Means p is giving the
Tell
left.
us.
P is giving the area of left
Okay.
side.
Left side. Where is it giving left side? So 5 root 5 is integral up to P I have written as. So you're confused about this. I have writing P as the integral of Z0 to infinity, okay? This is the definition of P value. The area of the tail, not left. Phi of 5, this is equal to 1 minus phi of right? This is equal to 1 minus phi of Z0. Remember, don't remember formula. Try to just see the area of the tail. That's all you need to do.
Yes, understood.
Try to find it for now. Try to find it for 99%, and 99% is you'll get it directly. You're getting the p value directly. Okay. So what I'll do is I'll add to this. I'll just do something like. Just give me a moment to gather my thoughts. Yeah. So what I'll do is now we have understood what happens when you have a sigma that is known to us. But in reality, is the standard deviation known to us? Is the standard deviation known to us in reality? Right? So we define the Z statistics. Let us write it down once again. How did you define the Z statistic as? X hat minus mu by sigma by root n. Yes or no? This is your statistic. And if it was greater than 1.96, we said that we discarded the null hypothesis. Yes or no? Agreed?
Yes.
But now, is the sigma known to us? Is it known in reality? Is it known in reality? Instead of what do we know? So we don't know sigma is not known. What do we know instead? Partho, what do we know? Actual standard deviation is not known. What standard deviation do we know?
Or like sample standard deviation that you were asking.
Yes, you know only the sample standard deviation, which is, if you recall, 1 minus 1 summation of I equal to 1 to n x minus x hat square. You remember this?
Yes.
And we showed in the previous class that n minus 1 sx squared by sigma squared is distributed is equal to, say, I equal to 1 to n x minus x hat by sigma whole square. What is the distribution of this? If you recall, can you recall? The standard deviation into n minus 1, we showed this. That sample variance, I told you I'll use it next class. Sample variance is distributed as chi-square n minus 1, right? It has the same distribution as
Yes.
a sum of n chi-square. So now I don't know, I have to define a different statistic. So I don't know this sigma. How will I define a statistic? You tell me. What will I do? So there is a statistic called T statistic that will help me to define this. I will define this very simply. Just if you follow me step by step, I will write this as x minus mu by sigma by root n. I'm just taking it to the numerator, and I will divide this by, or you can even write it at this way, Sx by root n. I will define this way. This is your new statistic. I am defining this as, okay. Instead of using the, what I am actually doing intuitively, I am replacing this by replacing actual standard deviation by sample standard deviation, right? Understood? That's what I'm doing. This is my sample standard deviation.
Yes.
So now tell me, what is the distribution of Sx? Sx distribution is, do you agree, sigma square by n minus 1 chi square n minus 1? From here, we showed last class that n minus 1 x squared sigma by sigma squared was chi square n minus 1. I just multiplied, cross multiplied the constants. Do you agree? Sx is distributed as sigma square by n minus 1 chi square n minus 1. Yes or no?
That should be Sx square. Yes.
Yeah. So Sx is distributed as what? Chi square n minus 1 sigma by n minus 1. Please go and look at this. I am trying to be as intuitive as possible, and in this case, I'm trying to derive the t statistic. So do you see, do you resemble this distribution? So now this is the statistic I'm testing, but in distribution, what will it look like? I'm trying to say actual distribution. How will it look like? What test do I need to do? Can I use the Z test? Can I use the Z table? I cannot use it here. Why? Can you tell me? So the actual distribution is X. I'm just putting the distributions, okay? Assume, so assumption is mu and Sx are independent. This is the only assumption. If we are not independent, I cannot just put it in the denominator, right? In the distribution form. A and B, if they are not independent, I can just not multiply them, right? If A is independent to B, then only I can multiply A by B. Right? We'll see why. Let us check. So Sx squared, Sx, I will just write it as, what will I write this as? Can you help me? I have already shown the distribution of Sx. Actual distribution I'm trying to find. What will I write? This is the distribution, right? Yes or
So
no?
like we will replace that.
Yes, we want to find the distribution. This is the value, right? This is the value. This value I know, but with respect to which distribution will I test? That distribution I want to find. I'll replace this. You're right. So I'll put sigma by root n. I'm putting this root n here into chi square n minus 1 by n minus 1. Okay.
Dada,
So
can I interrupt once?
Sure.
Yes, I had a question previously that we knew there was a theorem. You said that Sx can be modified as n by n minus 1 into the n by n minus 1 into Sx gives the original variance, original standard deviation.
That is expected value of that.
Okay, expected value. I thought of then we can replace that.
No, if on expected value you're getting, but we want the exact value, right? We don't want the expected value. We want the exact value on this distribution, something like this.
Yes, understood.
So do you see this distribution? We have already done this distribution in class. X hat minus mu by sigma root n by chi square n minus 1 by n minus 1. We have already done this in class. Yes or no?
Oh, Tn.
Very good. This is the Tn distribution or Tn minus 1 distribution. So for n samples, so now I will, so if you can tell me what will be my test? So my test will be the p value. What will it be? P will be equal to Tn minus 1 greater than equal to T, right? This is your p value, right? Understood? Instead of using the Z distribution, we are using the chi-square distribution. And we can use it directly because the mu, I am just replacing these two because the mu and the Z, what is the assumption in the chi-square distribution? in the t distribution, if you recall, a t distribution is z by chi-square n by n, right? Where z and chi-square are independent, right? Yes or no?
Yes.
So we just showed in the beginning of the class. So what will be the what will happen to? So what assumption must the mu and the standard deviation hold? If z and sigma square are independent, what assumption on sigma and what assumption on mu and sigma or and sx? What is the assumption I will take? What is the assumption? That they will also be independent, right? That the
Yes.
sample, the x hat and the standard deviation, they have to be independent. The sample mean and the sample standard deviation are considered to be independent, which is not true also, but that is the assumption of this test. So if I ask you now, the question is, if you're only given in this example, you are only given where is the question? Correct. So if your 10 was your sample standard deviation and not your actual standard deviation, what would you have done? What would your probability p value be? If sigma was your sx, if sx is equal to 10 and sigma not equal to 10, what would you do? So what would be your statistic? You check the probability of t. How many samples do you have? 500 minus 1, right? T 499 greater than equal to, what is the statistic value? Same thing, right? We have got the same, it will be the same value. Yes or no? 5 root 5. If your sigma was not the actual standard deviation, but the sample standard deviation, this would be your statistic, right? Again, P 499 also looks like a standard normal. So if you're not able to visualize, just think it is some way in the tail again. So it will again be significant.
Moinagda,
Huh.
means I was just away for about 5 to 6 minutes. Did you ask me anything during this?
No. I'm asking. I was asking regarding something, but that is okay. But Othi, did you understand? That's only the statistic, only the distribution I changed. Now, what I'll do is
One mathematical question that when we are
Yeah.
multiplying or dividing by a constant, then the distribution won't matter. Only it will get scaled.
Yes,
So
correct.
okay,
Exactly.
then fine.
You can check it yourself because it is the MGF will still be the same, right? You'll just have the MGF into some constant, right?
Yes, understood.
Good. So now the question is, you have understood what is t. So you see how we are integrating the t-test because we don't have the actual variance. We only know the sample variance. Okay, we have that part is clear. Now my question is, Otrij had
And
told
that
me.
sample variance is the biased estimator of the actual
Yes.
variance. Right?
So we had shown in the last class intuitively, if you were away in the last class, what did we show? We had shown that the sample variance was distributed as chi-square, right? Sample variance was chi-square n minus 1. So the denominator, if you're replacing by sample variance, so numerator becomes a normal, denominator becomes a chi-square. So your resultant distribution you should use to test should be a t distribution. That's what is used in your gate also and everywhere to normalize your score and not the normal distribution. Okay, I mathematically proved it. People will just give intuition. Just go back and see how I mathematically proved it again. Okay. Now, Yotrij, you had told me, do you remember that as n tends to infinity, what will happen to Tn? N tends to infinity, Tn goes to
0.
Z. We saw now that denominator of the chi-square goes to 1, right?
Oh, yes, yes. Expected value goes to 0. Yes, understood.
Expected value goes to 0, right? So the Tn goes to Z. So then that is why in books you may have seen that more than 50 samples, you will use a t-test, less than Z-test, less than 50 samples, you will use a t-test. Okay, that's why they mention it in the book. Because and we have just found all the mathematics for it. We don't even need to take heuristics. Okay, so I will do a very interesting question that will, I think, solve most of your doubts and help you to do modeling in t-distribution. So, and then we'll stop. The last question is just, I'll give you a broad intuition and we can stop. We'll stop by 10:10 today because we had started 15 minutes late. Now, we had done this test when the means were known. But say in real life, what happens, do you know? In real life, Partho, if you are a senior student, can you tell me what happens in machine learning in real life?
Machine learning in real life, we
Say,
just
just take accuracies. For example, you have accuracies, right? Two models, model M1
yes,
and model M gives you X1, X2, Xn accuracies, okay? There are n
yes,
accuracies. Similarly,
yes,
M2 has Y1, Y2, Yn. Till now, we were assuming we knew the mean, right? But now we say we don't know the mean. Even if we know, say, this is mu X, this is mu Y, and standard deviation is known to us also. But we don't want to see if it is different from the mean. What do we want to check? If model 1 is better than model 2, right? So,
yes, is how much do their means vary?
exactly. Do their means vary? So my question is, alternate hypothesis is, or null hypothesis is M1 and M2 are same models, are same performance models. Are, let us write, are models with same performance. If you're following, can you tell me one thing? For all these tests, what am I testing it against? Which statistic am I using to test? As in, which statistic is I'm using to infer that if it is
T
alternate.
statistic.
T statistic, Z statistic we derive. We are using comparing only means. Remember this.
Yes, means.
All these are mean comparisons. Okay. Carefully look at this question, which is very important. This will give you an idea how to decide on the distribution, because from up to now, you know how to manipulate or calculate distributions, but how to use them, you don't know. Let us see. H1 is, say, M2 and M1 are different. Let us not just for the time being say M1 and M2 is M2 is greater than M1. We can also do that. I can give you as a homework and you can try that. But for the time being, let us say M2 are different. So if they're different, do you agree? And say, so it will be two-sided tail. That is mean of y1 minus the mean of x minus y will be some normal. Agreed? Then I'll show you why. Let us assume it is a normal. Then if it is different from each other, then they will lie on both sides of the tail. Agreed? You can do for a single. This is called a two-sided test, two-tailed test. If you had shown M1 greater than M2, what would you have done, Uttrich? If I have to see if M1 is performing better than M2, what will I do? If they are different, I can use both sides of the tail. That is, M1 can be better than M2 and M2 can be greater than M1. But if I am strictly saying M1 is greater than M2, then what will I use?
Dada got a little confused. Means we have two given data sets. So here we are plotting x bar minus y bar.
Let us take it
two
step
tail
by
thing,
step.
can you say? Two tail.
Yeah, I will do it step by step. Let's take xi to be distributed as normal mu x sigma squared, right? Let us do it step by step. Agree? Do you agree to this?
Yes.
Y1. What is this distributed? Let us assume it to be distributed as mu y mu y, sigma squared. Assumption, both have same standard deviation. Same
This is
standard
actual or
deviation.
sample?
This is the actual, this is the assumption of the distribution, okay? We do not know. This is not known to us though, but this is the actual distribution, okay?
All right.
Yeah, but sigma squared not known, mu x, mu y known. I'll tell you why will it in general be known. So this is called an independent t-test, independent two sample t-test. Because we are taking these two samples to come from two independent models, right? These two models are not related to one another, right?
Yes.
And I'm seeing the performance of them. So now you tell me what is x hat distributed as? The average accuracy. Partho. First one Partho will tell, second one O3 you can tell.
Yes, please.
The average accuracy, what will it be distributed as?
Normal
Mu?
mu x
Huh?
plus mu y.
No, x cap. X cap is
Oh, okay, x cap, x cap. Mu
1 by
x.
n I equal to 1 to n xi y. Again, I'm writing 1 by n summation y equal to 1 to m yi sx square is equal to 1 by n minus 1 I equal to 1 to n x minus x cap whole square sy square is equal to 1 by m minus 1 I equal to 1 to m y minus y cap. Okay.
Yes. So mu x.
Mu x standard deviation will be sigma squared by
sigma square by n some n.
From here only you can write na directly. Again same calculation.
Yeah.
Expected value is
Expected value is
mu
mu sum.
and variance is sigma square by n.
Yes, yes, yes.
So now O3 tell me what is the distribution of mu hat y hat?
Is mu y
Huh?
sigma square by n.
N or m?
M.
Now you tell me, I have also taught this to you. What is the distribution of x minus y? Let's do it very step by step. What is the distribution of x minus y? If you recall.
Okay, they are independent, so mu x minus mu y.
Mu x minus mu y dependent independent always true because linearity is not dependent on independence, right? Expected value of x1 minus x2 is always equal to expected value of x1 minus x2. I had shown this in class. Does not depend on independence. Which depends on independent?
Okay, that is var of x.
Variance. So that is, what will it be? Addition of both this. I had given this as homework, right? And I did one sigma, I did x plus y. It was the addition of the variances, right?
Yes.
Good. Now I know the difference. Now you are asking this, right? So my difference will have a particular distribution, yes or no? X cap minus y cap has a distribution.
Yes.
With the mu of mu x minus mu y. And variance of x minus y is sigma root over of 1 by n plus 1 by m, right?
Yes.
Good. So my question is, so if for a particular value of x and y, which a sample is given to you, are they different from one another is what you need to check. So if you are different from one another, there you will get a sample of x minus y, yes or no? One of the means, you will get a difference of the means. These are, in reality, you will get sample means or not? Right? You will get some x naught minus some y naught, right?
Yes.
Yes. and they will be somewhere here once you scale them here or somewhere. Like Uttej, you were asking, what does different mean, right? Yes or no?
Yes.
If both of them are same, I am saying they will be 95% of the times in this range, right? Their distribution, the difference will be, right?
Yes.
What are we saying? We are saying that they're only different when they're in the tail, right? We showed that. So if they're different, there can be only 2.5% on one side. So this is called a two-sided test. Did you understand? They can be either side. That is, either x can be greater than y or y can be greater than x. But if you are told to test x greater than y, which side you have to test?
X greater than y, then we have to test the positive tail.
Only this side. So this will be 5%. Good. Understood, Uttris? This was your question. I have drawn with red. It will come. It will come in 1 second. Yes or no?
Oh, yes. Understood.
Okay. That is okay. Now, let us now tell me what. Let us define a. Now we need to find this statistic, right? Some statistics. Let us define this as z, right? This z, what will be the statistic? Do you agree? It is x minus this minus mu x minus mu y. I am just rescaling by sigma common 1 by n plus 1 by n, right?
Yes, yes, yes.
From this distribution, is it okay, Uttrich?
Yes, Dada.
Good. Now tell me what is the problem. If I already knew sigma, problem solved. Yes or no? I can use z distribution, right? Sigma known. Directly use with distribution. Which test? Directly use z test.
Oh, acha. এখানে তো we only know s of x and s of y.
Very good. We do not know
These are
sigma.
unbiased estimators of sigma.
Yes. So I have to replace this in terms of some sigma tilde. But I do not know how to replace. It is not obvious here. But let us see some significant things like these. For example, do you know sx square n minus 1 by sigma squared is distributed as chi square n minus 1? Do you agree? I have shown last class and we use it just now again.
Yes.
Again, then you tell me sy square m minus 1 by sigma square, what is it distributed as? Chi square?
M minus 1.
Finding the distribution, the stat and the distribution. M minus 1. Now, if I add these two, what will happen? Can you tell me?
Okay, chi-square freedoms get added.
Good. So if I add sx squared plus sy squared in some way, I will get addition of n minus 1 squared, sigma squared, chi square n minus 1. Oh, let us just add first both of these in this way. So sx squared n minus 1 by sigma squared plus sy squared m minus 1 sigma squared. Partho, what happens when you add two chi square?
There are degrees of
Freedom gets
get
added.
added up. M plus
Good.
n minus 2.
Good. Now I will do one very, very nice trick. What trick? I will divide this by m plus n minus 2 and I will divide this by m plus n minus 2. Okay. You like this trick or not? And you will see why I define this as u. Okay. Or let us define this as sigma common or something like that. Give me a name now for this. Sigma nu, let us write. Sigma square nu. Okay. Now, is this clear? This step is clear, right? That this distribution will be this. Both sides are clear?
Yes.
Now, can I define a statistic like this? A t statistics again, which is x minus mu x. Let us write x cap minus y cap normally, normal. So I'm just writing this. Okay, this z. Okay. I'm just using this z. I am going to use the t statistic as z by. What am I going to use? Can you help me? What is Tn? Is z by chi squared by n? Yes or no? This is what we have seen. We want to bring a t distribution. How will we bring? Come up with it. Take this u only. Now tell me, is it okay? Is this giving you an intuition of chi-square? I will show it why it is chi-square. Okay, where z is, we have defined z as x cap minus y cap minus mu x minus mu y by sigma 1 plus n 1 plus n. Okay, but now this is my new number, new t statistic. I have defined this way, and you may ask me, how did I define? This is from the practice. Just now see what will happen. So can you tell me what is this distributed as? What is this sample from? Am I audible?
Yes.
T distribution.
It is a t distribution sample, but do you see? I will just put the values and I will show you. X minus mu minus. So I can write this as x minus mu x minus y minus mu y, right?
Yes.
By sigma 1 plus n, right? This is my z. Z by
Yeah.
u. What is my u? U is chi-square m plus n. Let us get the value, actual value first, then I will write what is it. It is sx squared n minus 1 by sigma squared. As sigma squared, let me take common. 1 by sigma plus sy squared m minus 1 n plus m minus 2. Right? Yes or no?
Yes.
So I cut this two. I get this becomes your t statistic, which is also shown in your books. But derivation is you have to do yourself. That's why I did the derivation. Your library uses this. So this is referred to as sigma common in most of the books. Sigma common 1 by n plus 1 by n. So the intuitively, sigma common is what? It is a proxy for this actual sigma, which we don't know, but we know only samples from, right? Right, Partho?
Actual sigma we don't know.
Yes, that's why I canceled them,
Yes.
right? So I.
A second.
Tell.
Sigma. Fine. Yes.
So that's why I am taking the sample estimate and replacing it. Now, what is the distribution of this? Can you tell me? It's one liner. What is u? We showed this distribute. It is z by chi-squared m plus n minus 2 by m plus n minus 2. Right?
Yes.
Two tests. So now, if I am telling you to do this test, you will do how many dimensional kite test? You will do
M plus n minus 2.
2, and you will see if it is different from this t statistic that we found, t. Right? Okay.
Yes.
Good. So my one question I'll give you, and it will be a homework. Say you can use a computer to calculate it. Say x hat is given to you, right? For say six cases of a model from one model. The x is 56%, 56%, 65%, 58%, and if 61%. Four of these, and y is 65%, 70%, 55%. They are not related to one another. Remember that. 56%, and so on. And 68%, say, for different numbers. My question to you is to see that, let us take, I'll give you the mu x also. Mu x, say, is given 60%. This is known by some heuristics, and mu y is known that it occurs to be some 60% again. Both are 60%. They are known from the basics. They should be 60%. So that you can simply get 0. That's why I'm giving you this simple. Both are 60%. I am telling you to check case 1 is x different from y. Case 2 is y greater than x. Okay. These two cases you check and tell me. Go through this entire proof once. It is, for me also, it took 10 times when I learned statistical tests, because it's very rewiring things that you have already learned. So once you look at it 3-4 times over the weekend, you will be able to solve it. This is a very important question. Try this as homework. I have solved all the questions in class. That's why I have given extra different homework. Okay, the last topic for today is, and last topic for statistic is chi-square test, and I will not show the proof for it. I'll just show you the method because it's very simple. The chi-square test is done when you have categorical data. That is, when you have categorical data, say you have C1, C2, CK. In K categories, the data can be. So let us write it down. So I'll do it at the end, chi-square test, and then if there's too much jumbled up otherwise. Say you have chi-square test done for categorical data. For till now, we were doing comparing means. Now we are comparing PMFs. Compared PMF. What are we comparing now? PMFs, probability mass function that we were using. Okay, so the chi-square test. What is the chi-square test? Let us understand. Say you have, I'll give you a simple, nice example. Bengali, English, Hindi, and some other languages are there. Okay, and there are 1,000 clips given to you, right? 1,000 clips are given to you. These 1,000 clips will be going into one of these categories with some probability. Do you agree? When you have a clip, an audio clip, they will be belonging to one of these category of languages with some probability P. Okay?
Yes.
So if I am giving you the PMF to you, I am giving the PMF to you, say P1, P2, ... Pk, and I give you data. Then you have to tell me if the data and the PMF are same. Are they same or different? Okay, same way. There's nothing different. You have to check if they are same or different. Okay, so let there be n examples. Okay, so let there be n
Dada,
data points.
sorry to interrupt. What are the PIs? Please repeat.
PIs are the probability of a clip being in a particular language.
Acha, acha, okay.
What is the probability that a particular sentence will be spoken in a particular language? Actual probability. Okay. But in
Acha.
data, you are only given M1, M2, M3, and MK, right? MK being number of data points in each language. For
Okay,
this
for
current,
putting a new sample, what are the PIs that we are given?
yes, that is given. For even
Acha.
if you have a random sample, what is the probability of going to one of these languages is given. So the summation of PI is equal to 1. Remember that. I equal to 1 to K. Right? Also, do you agree? Mi by n summation is equal to n, or again 1, sorry. Yes or no?
Yes, yes.
Number of data points is equal to total number of data points in each class is equal to total number of data points. Good.
Yes.
So now I will have two quantities. The new quantity that I will have, this is expected. So let me just see what notation I use. I'll just copy the notation once. So just to avoid any confusion. Yeah. So I have used the notation x size. X size is the expected number. Okay. Okay. So what is the, so if I ask you what is the expected number in each class, x, what will you say? Xi is how much? What will you say?
NPI.
Mi by n from the data. This is actual.
Yes.
So this is observed from data, and PIs are given to you, right?
আচ্ছা
Huh? Xi
তুমি কি অবজার্ভটা বললে না এক্সপেক্টেড বললে?
observed.
আচ্ছা অবজার্ভটা বললে। আচ্ছা
Expected I have already been given PIs. In the beginning of the definition only I told you P1 to PK is the actual probability. Okay. So what do I know? Summation of I equal to 1 to K. What is going to be Xi? Is going to be 1, right? Yes or no?
Yes.
Okay. So the statistic that is used, which Pearson showed, is this. I equal to 1 to K. Xi, I'll give you the intuition, but not the proof. Proof has to be done by induction. Very simple, same as the one that we did for showing that sample covariance is equal to chi-square n minus 1. It's the same proof. You can try it yourself and upload it in the Teams. Let's do it for. So Xi is the observed number. Or yeah. Mi. So I think I have mixed up notation. Just to be, I'll be just bear with me a bit. I'll just copy the notation once again. The notation is very important, otherwise you'll mix up things. Where is it? Mi is the I'll just copy this entire thing just to so that you don't see a problem. Just give me one moment. Yeah, copied it. Okay. The broad intuition is clear. I'll just write down the math and then it will be like done. It is not confuse notations. Yeah, done. So it is given that is for categorical data. PI, as I was telling you, is the probability of being in a particular category. MI is the expected number that is equal to NPI. Okay, agreed? What is the expected number? So let us have two tables right here instead of having, so xi is not, xi's are the values that I observe. So now if I ask you what is the expected number of number, then what will you tell me? Expected number of trials in a category. What will it be?
NPI.
Yeah, so it is number of samples is n, number of examples is n, and pi is the number of, is the probability that it belongs to a particular class. This is what I am expressing as mi. Okay. Xi is the observed in data. So you will be asked if mi's are different from xi's. Is it okay, Utkarsh? Is the notation clear? I mixed the notation up.
Yeah, yes.
Okay, so if it is clear, just tell me what would be. So Pearson showed that chi square equal to 1 to k xi minus mi squared by mi goes to chi squared k minus 1. I'll show it why. Intuitively, I'll show it and then you can prove it using induction like I did it for sample covariance. So what can I write the numerator as? Xi squared plus mi squared minus 2m ixi, yes or no?
Yes.
So what is this? Xi squared by mi, right? I equal to 1 to k. Agreed?
Yes.
Plus k into mi, or plus summation of mi, I equal to 1 to k. Yes or no? Minus summation of xi, I equal to 1 to k. Yes or no?
Yes.
So what is summation of mi? I equal to 1 to k.
N.
In pi, right?
Huh? Summation of mi is NPI.
Summation of
Summation.
npi. I'm just putting the formula of mi.
It will
It's
become
what
n.
expected. Sorry. Hey, yes. It's expected mi.
Yeah, so this is equal to 1, so it goes to n.
Or 1, n.
This is also n. Summation of xi by definition is equal to n.
Yes.
2n.
N minus 2n, so it's minus n.
Yeah. So this is also a, this is how you calculate it. You can use this formula to calculate things, but the overall intuition is this. What distribution will I use? So this is your statistic. This is your, so statistic is the value in a distribution. Which statistic, again I'm telling, statistic S is a value in the distribution with after whose tail you want to calculate, and say the tail has low probability or high probability. Okay, but it has to be with respect to a distribution, right? What distribution will it be? Intuitively, what is going to be? So xi squared,
Maybe it
right?
is a sum of xi's, sum of square of xi, so chi squared hobe of degree
Let
k,
us,
I guess.
yeah, let us do that. Let us do it simply. Like let's take a simple example. So what is this xi? Summation xi is the observed, right? Do you agree? Xi's are the observed, yes or no?
Yes.
Okay. So if xi's are observed, then what can I do? I can replace, and mi is the mean, right or wrong? Is sort of the mean, which is expected. And these are numbers, right? Do you agree? They're numbers or not?
Yes. Mi is the mean of xi, means xi will become mi.
mi is the expected number of it's npi, right? It's the expected number, right?
Ha. That is okay.
Yes. So what I'm taking is I'm taking n common. If I take n common, do you see I will get xi by n minus pi? Yes or no? Correct? Yes or no?
Yes.
So numerator is like what? Mean minus actual mean squared. Yes or no? The distribution observed minus actual squared. Yes or no?
Yes.
What is the denominator like? Denominator is like mi by n, which is pi, right? Agreed? Yes or no? Mi by n is pi by definition. So pi by n. So the intuition is being, so pi by n, in normal cases, you will have pi minus 1 minus pi as your variance, yes or no? For a multinomial case, as we proved for a Bernoulli, monomial also has the same variance. Right? This is going to be your sigma squared. Yes or no? Sigma squared for normal sigma square of a multinomial is going to be p into 1 minus p by n, right? If I am taking it for n samples. Yes or no? What is Bernoulli's distribution? Bernoulli is sigma of Bernoulli is p into 1 minus p. Yes or no?
Yes.
Good. So if it is a multinomial, there are C classes. Can you treat it as Bernoulli or not? Pi is for class I, rest classes is 1 minus pi. Yes or no?
Yes, we can treat.
You can treat it as Bernoulli only. So you can use the same sigma square can be for n samples can be the same thing, right? Sigma, the Bernoulli is going to be the same thing. Okay. The actual variance is going to be the probably the same, but we are seeing pi instead of 1 minus pi. The rough intuition being, if you have large number of classes, this is going to go to 1 in case you have a large number of classes, and then you can replace this as a proxy for sigma square, which is similar to chi-square k minus 1. Yes or no? Which we have already shown. X minus mu by sigma whole square for k terms is equal to chi-square n minus 1, right?
Yes.
But it is exactly not true. It can be done for finite samples also, but that you can see if you do it for by induction and by just show it for finite samples. But this is the intuition. It was shown by Pearson that it is chi-square n minus 1. So you have to calculate this thing and then see if this statistics, say, let us represent it as k square if chi-square is greater than or equal to k square, and see if it is significantly different, then they are different, otherwise they are the same, right?
Oh, so I have to from the chi-square table
K
with the
minus 1, yes.
degree of k minus 1, I have to check that it is significantly difference from this value or not.
Whether this value is in the tail or not, as I was telling, that this is the statistic. chi-square will give you a entire distribution, right?
Yes.
Whether it is in the tail, you have to check. I have a
Acha,
simple
whether it
example.
is in the
Hmm.
tail mane, there should be a level of significance with which I
Point,
must, I must
point, 0.05, 0.001. That's how you represent
fine.
in papers. Yeah. But you can exactly find the tail value, right? This is the difference of the in a confidence interval, you need that value, but in the p-value, you can exactly get the p-value, right? Because p-value is the area of the tail,
Yeah.
as we have discussed. So I will just intuitively give you this example. So I have completed all the statistics portion. I'll just do it for this example. I'll just write down few numbers and the rest you can do it as homework. It is generally used for things like these, whether a city given an occupation is independent. That is, whether a city is independent of its occupation. Say I have this table where city A is given, observed, expected, B is given, observed, expected, observed, expected, right? And I have doctors, professors, and IT professionals given to me, right? These are three given to me. My question to you is, the question is, probability of the city is independent of the occupation. What does it mean? Can you tell me what information does it give me? Anyone, can you tell me?
That they were mane, the city
Yes,
does not influence the occupation, means they
correct.
are uncorrelated.
Yes, then what? Like uncorrelated, they're independent, not even uncorrelated.
Yes, they're independent.
How to? So what is? So to find out the independent distribution, how will I do that? Any idea?
So I'll take the column wise and the row wise sums.
I don't want to know the way procedure. I want to know the reasoning. Procedure you will do. I will tell you to do.
For independence, I have to check that whether their combined distribution is the product of their marginals.
Correct. Then what does that mean?
What does that mean, Manu?
What? How can I get intuitive? Like how can I use it directly to get the expected value? Observed, I already know. How will I get the expected value is my question.
Yeah, so the expected value doctors from A, so the all total number of people, no. Act a second.
Independent means they will have same proportion, right? You just told me just now. Same proportion of occupation in each city.
Yep. Yes.
O3, yes or no? Independence means they would be having the same proportion of occupation. So if they don't have,
Yes.
they have different proportion of occupation, then you don't have independence, right? So
Yes.
how many people are there in of the total population? How many are there in city A? 1/3. Yes or no? City A contains
Yes.
1/3 of the people. City B contains how many people? 2
Uh,
by 1 by 12. Is it? Wait, 20, 10 by 10 by 24, 5 by 12, right? 5 by 12. And city C contains
yes. 1/4.
1 by 4. So 1 by 4 of the population it contains. Similarly, doctors are 1/3 of the population. Professors are 210 by 480. That is how much? 7 by 12 part of the population. Is it? 16. 7 by 16, right? And this is 11 by 48 part of the population. So now you tell me same proportion of populations in each city. Occupation in each city. So 1/3 of 160 people will be in city A, yes or no? City A contains 1/3 of the people expected. Just NP.
Yes.
Yes or no? City B will contain 160 into 5 by 12. City C will contain
Yes.
160 into 1 by 4. Similarly, you
Yeah.
can fill the table, and then what will your Z statistics be? So for the first number, what will it be? X11. This is gonna be 160 by
10 by
3
3 whole square.
minus 50 whole square by the expected value.
By the expected, yes.
And you have to do
10
it
by
for
3
all.
whole square by 160 by 3.
Write a code to do this. Okay. And you will add x11 plus x22 and so on, and you will get a number. But now you will get a number. This is your statistics. This is so very calculative. But you will test it with respect to which distribution? Chi-square. What is the value of chi-square will it be? To see
Chi-square of all the number of samples, which is 9. So chi-square 8-degree freedom.
So, but there are two variables here. So degrees of freedoms will multiply, not add. When number of random variables are greater than 1, your degrees of freedom multiply. So what is the number of degrees of freedom? 3 minus 1 into 3 minus 1 equal to 4. Okay.
এই জায়গাটা একটু আজব লাগলো মানে কি
It
হলো
is,
ব্যাপারটা
you have to do it. So these are not samples, single samples, right? They are different samples.
yes sir.
So each row has 3 samples, right? So you can take them as different random variables. So once you take them as different random variables, they will have joint distributions. So when you have joint distributions, what will you expect the degrees of freedoms to be? They're not independent anymore, right? So you would expect them to be the product of the joints.
Multiply. Yes.
But it is still very heuristic explanation I'm giving, because if I have to give this explanation, this only will take one class, this entire chi-square test. This is why I kept it for the last, and I wanted you to remember this. But I have given you all the foundations for you to go and derive it on your own, right? So there's nothing new that is required. You know all the distributions, you know that sample variance goes to chi-square, and you know joint distributions very thoroughly. So with that, I'll stop recording for today, and if I have questions, I'll take after that.